The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, my name is Guy and I'm from IT Masters. Thank you for joining us for the fourth and final VMware vSphere 6 Masterclass short course live lecture facilitated by IT Masters and ITPA, or the Information Technology Professionals Association, which is presented by ITPA President Robert Hudson. This week Robert will discuss advanced operations. As always, we encourage you to ask questions throughout the live lecture via the chat function, and I will endeavour to answer them if they are logistical or technical issues via chat, or if they're relevant to Robert's lecture, he'll address them as we go. Just some housekeeping this week before getting into things, as this is the last lecture. Next week, from Wednesday the 16th of November, the course exam will be available to students. You will have until 11:59 Australian Eastern Daylight Saving Time on the 23rd of November, so basically a full week to complete it. Despite this, it's best not to leave it until the last minute in case of technical difficulties, because we can't help you if you miss the cutoff, unless there's a very extreme case. You are required to complete the weekly quizzes from weeks 1 to 4 before you can access the exam and earn your certificate. The quizzes too can be taken until the close of the exam period, and thereby unlocking the exam. But again, we recommend not leaving this until the last moment, because you will not be able to sit the exam without having first completed the quizzes, and studies show cramming isn't your best option, and again, technical issues may get in the way. The exam consists of 40 multiple choice questions, which you will have 1 hour to complete. The questions are from content presented in Robert's webinars, weeks 1 to 4, so if you want to revise, you can just go through and listen to those again, or all the course content which is on the IT Masters Moodle page. Please note the exam can only be attempted once, therefore do not attempt the exam until you feel you are ready to take it after revising. A reminder email will be sent out once the exam is available, and should you have any technical difficulties, please email us as soon as possible at shortcourses@itmasters.edu.au. I'll post that email in a second. And for those of you that are worried, Robert will repeat the exam information at the end of his lecture. So that's so don't worry, don't ask too many questions now. We'll get to that at the end again. Just one last request. We have a quiz, not a quiz. It's more once you've completed the course. We really appreciate if you take a couple of extra minutes to complete our course satisfaction survey quiz. Basically, you'll find that at the bottom of the learn.itmasters webpage, and the link is found at the bottom of that page, as I said. This quiz basically is a feedback quiz. It contains a few questions related to the short course that you've just completed, and your answers will be reviewed at the conclusion of the exam period by the IT Masters administration team as part of our improvement strategy. Your feedback is very valuable, and any feedback you can provide will make future courses better, so we really appreciate if you do jump on there and let us know what you're thinking. And lastly, if you can't get enough of our courses, or if you have any inquiries about CSU courses, possible credits, your eligibility, or any questions at all, please contact Neil McCosh, who will be glad to assist you at nmccosh@csu.edu.au. I'll post that link as well. But for now, I think I've spoken far too much. It's time for the proper speaker. It's time for Robert, so please welcome Robert.
Thank you, Guy, and thank you for calling me proper. I don't think I've been called that very often. Look, everybody, thank you. We're at the last week of lectures. So this is, as we know, the VMware 6 Masterclass, week 4, Advanced Operations, as Guy mentioned. So we've gone through some basic information around vCenter, some information on virtual networking, virtual storage, and advanced operations. What you know we haven't done is we haven't spent a lot of time actually looking at VMs themselves, because really they haven't changed a lot, and there's not a lot to them. We sort of had a look at briefly what they are, and if you want to get really into the nitty-gritty of how they're built, I'm happy to answer questions in the forums, but we decided that we didn't want to put that into this masterclass course. It just didn't seem to fit well without taking away from some of the other topics. So this week, as I mentioned, week 4, Advanced Operations. However, this is where I put my President of ITPA hat on. A brief word about the ITPA, or Information Technology Professionals Association, as we've noticed. So We are a not-for-profit organisation. We are led by IT professionals who currently work in the industry. So none of us are professional managers of not-for-profit organisations. We are all IT professionals. So we are working in the industry. We have a passion for the industry. We are in tune with what is going on in the industry. And we are excited about the industry. You know, this is not a vocation or a profession that we choose because we think it pays lots of money but is boring as all hell. It's something that we tend to all be very passionate and excited about. So the organisation is run by a group of people who really care about the industry and where the industry is going and the way the industry is treated and viewed by society, government and commercial entity. We are certainly focused on growing career opportunities for Australian IT professionals. We are looking at, and the online short courses that we'll be offering once a quarter are primarily aimed at improving the level of education within the Australian IT community. We hope that that will then assist the providers of IT service and people who work in the industry to provide better service to their customers, be those customers commercial entities, government, society in general, and certainly to raise awareness of issues that have either a significant facet of them is related to technology, or where technology actually then has an impact on other issues. And we are willing to challenge government policy on those issues. We're certainly not afraid to disagree with them. We don't rely on government friendliness for our existence. So we're not afraid to challenge when we think it's worth it. By the same token, we're very happy to compliment and approve where we believe it's appropriate, and things like the mandatory breach notification laws are something that we do support. We believe they are important, and so we do support that kind of policy out of government. So membership, there is a free level of membership, and having signed up for this course, you've actually been granted that associate membership. However, we do have a professional membership level, and that level allows you access to further services that we offer. And the cost of that is $165 per year. There is a $30 admin/joining fee, and that covers some of our costs in actually setting up your membership, providing you with some tangible items as part of your membership, your joining your membership. And then the $165 per year, which we think is very cost effective, but certainly quite affordable in the market that we play in. We think that that is a fair price for what we're offering. Now, $165 is about a cup of coffee a week, just to give you some idea of scale and scope in there. Certified practicing member, and I mentioned before that we are aiming to promote education within the industry. So this is our CPD, continuing professional development program, where we aim to recognise members who are continuing their education as they practice. And then we do have a life membership, which is a membership that we grant to a very limited number of people who have contributed significantly to the organisation or to the IT profession in Australia. I mentioned the CPM, our Certified Practicing Member. Some of the more senior people in the group may recognise that CPM was also an acronym used many years ago for something else. To qualify for our CPM program, you need to attend and pass with a credit, I think is the score, one of these online short courses. Characters per minute, that is one use of the term. What you'd be looking at is a operating system that precedes DOS. Yep, Nathaniel's got it. CPM 86, exactly.
What's a CPM 86?
CPM 86 is the operating system that preceded MS-DOS.
Oh, there you go.
You're looking back in the 80s, late 70s, early 80s.
Maybe an 86.
86 is the CPU family, the 8086 family of Intel CPUs.
I'm showing my technical knowledge here.
Is it supported on somebody's asked, I think possibly tongue in cheek, is it supported on ESXi? I think you could possibly make it run, but geez, it'd be quick. A lot of those.
Try it in your lab. Try it in your lab.
Yeah, try it and post in the forums. It's possible to download CPM code still, so that is available. But back on, there were different versions of CPM for different platforms. So Adam has made a comment that Commodore 128 could also run CPM. I'll go back to the course content though, because otherwise we will spend all night talking about history, and I'll start talking about my $4,000 80486 system. Half the cost was RAM, and yeah, we'll talk about the good old days when we walked uphill both ways to and from work, things like that. I shall get back to the content. So the CPM program is really about continuing education for our members. We're going to be promoting it both on our website and in the media. There will be a post-nominal designation that those who are passing have gained access to the CPM program and are maintaining CPD or PDUs per year will be able to use. And certainly the long-term aim is to position the ITPA CPM as the IT industry equivalent of a CPA. So we want that level of recognition that we are continuing to educate and enhance the level of practice of IT of our members. How can you get involved? At the very least, and you guys have all done this, get your voice heard by staying as an associate member. So you are now an associate member. Please stay with us. It doesn't cost anything. Okay, and what we will do is that we will speak on various matters to the press, to the government, to industry that we feel are important to our members, and you will have an ability to make your voice heard internally within the organisation, and then we will voice that, we will project that voice externally. Please consider becoming a paid member. As I said, it's a cup of coffee a week. What is the difference between the ITPA and the ACS? We are different organisations, a little bit different focused. Take that one offline if we may, otherwise I'm going to spend all night, and I could easily do it, discussing ITPA. Pass the word, tell people about us, tell people you're doing our short course, you think it's good, bad and different. You know, if you think it's bad, tell us. If you think it's great, tell everybody. Tell your friends, your peers, your relatives, your pets, and if you can get your pet to sign up, that'd be awesome. I'd love to see a pet sign up. Not you signing up on behalf of your pet, I want your pet to sign up. That'd be really cool training. If there are questions, let's go along with it. No, I don't want you to sign your pet up, Nathaniel. I want your pet to sign up. Difference. I am joking, of course. You actually need to be a natural person in a legal sense. Sorry. Do degree credits count towards PDUs? They can, yes. I'm going to suggest we get on with the content. Are we planning more of these short courses? Yes, we are, 1 a quarter. Happy to answer all sorts of questions on this. I really do want to get into the content. So week 4, advanced operations. So what we're looking at, and it's not all advanced operations, I chose some that I thought were important and worth knowing. And the one we'll spend probably the most time focusing on right here will be vSphere clustering and some of the different things that happen within clustering. We'll also look at vCenter security, how that's applied, where the security model that is employed in the vSphere environment. We'll have a quick look at vShield, not a massive look, and then just again discussing the lab setup. So without further ado, we shall talk about vSphere clustering. Does this benefit you if you are not in Australia? Potentially. I'd recommend, and last thing I'll say about ITPA for now, is go look at our website. It is www.itpa.org, that's org.au. Have a look at what's there. We'll certainly, being recognised as having CPM, our CPM certification will help your career. Certainly learning will help your career. There's no requirement to be in Australia to learn. We're not the global centre for that. But certainly we think we're in an interesting place. We'll be representing member interests largely to Australian government and business, but certainly being a member and being outside of Australia, and we do have some members from overseas already, there's a value to that, whether you determine that is a financial value that you wish to pay for or are happy to stay as an associate member. That's a value decision you can make. We shall get back on now to vSphere clustering, if I may. So, in the beginning, there was single host virtualization. So you get your standalone ESXi hosts, and they provide a level of abstraction between the workload, your virtual machines, and your physical hardware on a single physical host. So you get virtual CPU, where you get the ability to oversubscribe your CPU to assign more virtual machine or virtual CPUs than you have physical CPUs. Your ability to schedule your CPU workloads amongst those virtual CPUs onto your physical CPUs. You get that on a standalone host. Virtual RAM, again, you can oversubscribe, so you may have 32 gig of RAM, 64 gig of RAM. I've got virtual hosts with 768 gig of RAM in them, and you can actually allocate more RAM into your virtual machines than you have physical RAM. VMware does some really cool stuff in their memory oversubscription. It's different to what Hyper-V does in that sense. Hyper-V does it one particular way. VMware have some, I believe the patents are still standing, methods of doing it that are quite different, and I think more efficient. Microsoft will argue that they're getting better, and I probably struggle to disagree with them that they're getting better, but certainly VMware has had the advantage in that area for a long time. You also get virtual disk. Again, the fact that you can thin provision, and that's certainly part of standalone ESXi. There's nothing to stop you doing that on a standalone box. Your VMDK files, so your virtual machines believe they have a disk, which is actually a virtual construct, which is built into a file in the VMFS or NFS file systems that we talked about last week. And also virtual peripherals, so you can have virtual USB ports, virtual serial ports, virtual parallel ports, virtual, there's a few other different items you can add to your virtual machines. The ones I've spoken about are the primary ones, that again, that you can have, they can either share devices or you can lock them to devices. Probably not as big a benefit in standalone virtual hosting as you may get in clustering, which we'll get to in a moment, but the capability is there. You can certainly build a virtual machine and attach that to a physical peripheral through virtualization. You can do that. Now, you don't get redundancy or resilience in the event of a hardware failure. So if that one host falls over, all your VMs fall over. You can have redundancy that comes from redundancy that's built into the host. So you might have multiple power supplies, RAID in your storage array within your host. So you might have RAID 5, which allows a single disk failure to not destroy all your data. Multiple PSUs, as I mentioned. So if one power supply fails, the other one keeps running. But you don't get the ability that if a host falls over, your virtual machines come up somewhere else because there's nowhere else to come up. Now, and this really gives you, there's reduced feature availability versus vSphere virtual infrastructure or vCenter. There's some features that simply are not available on standalone ESXi. And what that looks like is this. Again, people have asked for pictures, so there are some pictures. So you have a bare metal server, which you can see here. The VMware ESXi hypervisor has been loaded onto that bare metal server, and your virtual machines run, and they have their applications sitting in their operating systems in those virtual machines. You get segregation, so instead of, in the past, if you ran, let's say the operating system here was Windows and all of these, you would run Windows up on your bare metal and run a number of applications on that Windows install, and those applications may clash with each other, they may compete with each other for various resources. Virtualization allows you to remove some of that clashing. Certainly there's no reason, and in fact there's almost no possibility of a software clash between the application in the first virtual machine and an application in the second virtual machine, because the access to the infrastructure that they rely on has been abstracted by the hypervisor. So there's some of the benefits you do get out of single host virtualization. It is a valid option for some people. It provides enough benefit that they don't need to look at clustering, because clustering does add cost. And you can do this on a free version of ESXi, so you don't have to pay to be able to do this. However, when we start looking at vSphere virtual infrastructure, we get some benefits. So the way virtual infrastructure tends to work is you have clustered ESXi hosts. They are managed by vCenter, so you get a central point of management, and they allow a greater level of resilience because you get better hardware redundancy. Even with clusters, you would still have your host having multiple power supplies, and multiple they might have if they've got built-in disk, and that's whether you use inbuilt disk or shared resources, which I'll get to in a second. But there's a greater level of redundancy because your virtual machines are able to move from one host to another. So if a host does fall over, there is at least one other host that can take on the workload. So you remove that single point of failure, that one host falling over, the cleaner unplugging the host to plug in the vacuum cleaner, as is the old stereotype, doesn't take your entire environment down. It may crash it momentarily, and you get what we call crash recovery in a high availability or HA environment, but it does, it will bring the virtual machines back online for you. So you don't have to wait until somebody comes in the morning, oh gee, somebody's pulled the power out and all my workloads haven't been running overnight, which means my backups didn't run or things like that. You avoid that failure mode. You get to utilize shared resources. So shared storage is probably the biggest kind of shared resource. You know, the fact that these hosts, if they're going to allow HA and DRS activities with vMotion and things like that, they need to have access to common storage. That might be done through vSphere, which again we spoke about last week. Yeah, you get access to this now. Yes, there's additional cost in this, but it provides a higher level of availability and resilience and possibly even performance. I say performance because in general, if you have a SAN, it will probably have more disks to spread the workload across than disk built into a host in general broad terms, which means you overall get better performance, and if your workloads don't compete for that performance regularly, then each workload effectively gets the full performance of the SAN, and that's something that, again, I mentioned last week in the storage lecture. So there are two types of clustering. There is dynamic resource scheduler or DRS clustering, and there is high availability or HA clustering. Although they are both clusters, and they can actually, you can also have DRS plus HA or HA plus DRS, as I call it later. Clusters, so where one cluster does both functions, each functionality provides a different set of, or each of those types of cluster provides a different set of functionality. So you also get advanced functionality to maintain availability and performance of your virtual workloads. I mentioned before the centralized management of your hosts and your VMs. So vCenter allows you a single pane of glass to look at your entire environment and to orchestrate activity and to manage and monitor that environment. You also get some of the additional features which I mentioned earlier are not present in single host virtual infrastructure. vMotion, storage vMotion, network I/O control, if you have the higher level licenses, distributed vSwitches, things like that. You simply don't get that capability on a single host running free with no vCenter. Okay, so clustering. So the way clustering works is that your ESXi hosts are added to the cluster. So when you, in your vCenter environment, you will point the vCenter services at one of your ESXi hosts. You'll provide it with provide your vCenter environment with authentication in order to achieve this. But the ESXi host moves from a standalone environment to managed by vCenter, which provides, as I mentioned, automation and control of processes across the cluster. So it actually, not only does it allow you to say, move this VM from here to here, it actually monitors all the hosts in the cluster and all the VMs and ensures that the operations that are occurring are being managed rather than happening independently of each other. So when you add a host to vCenter in a cluster, there are two management agents that are installed onto each ESXi host. They are called or named hostd and a VPXA. So sometimes, just as a tip, that if you have a virtual host, so a virtual host, an ESXi host in a cluster that is not behaving itself, you either can't contact it. vCenter says I can't contact the host. I can see it's there, but it's not responding to commands. Or if you put a host into maintenance mode and it won't come back out of maintenance mode, or it won't enter maintenance mode correctly even though all the VMs have been moved off it, it's generally a fault of one of these two processes that is causing that issue. And sometimes, if you look at the VMware KBs on some of those kinds of issues where a host is stuck in maintenance mode or a host won't enter maintenance mode, the response often in those KBs is that you should go and restart these two services. And that will generally bring a host back into line in its cluster. As I mentioned before, clusters can run in DRS mode, HA mode, or both DRS and HA modes. So if you're running HA on the cluster, so high availability, at least one of the hosts, in fact it says at least one, it's one of the hosts, is elected as the master host within the cluster. So one of the things a lot of people will ask is, so if my vCenter server goes down, does that mean all my vCenter functionality goes away? So do I lose my HA? Do I lose my DRS? Do I lose my ability to perform or to continue with operations such as vMotion, storage vMotion? And the answer to that is no, and this is why. So effectively, One of the hosts in the cluster is elected the master and the rest become slaves. The master is responsible for monitoring the slave hosts and initiating VM restarts if a host goes missing. The way that is done is that vCenter writes or gives some instructions to the master to say, in the event of this kind of failure, go and do this. It monitors the power state of the protected VMs, restarting if a VM fails. So if a VM falls over, the master is responsible for telling the host on which that VM sits, go restart that virtual machine. It also manages the list of cluster hosts and the protected virtual machines. So that list of, if I've got a cluster of 3 hosts and I've got 60 virtual machines across those 3 hosts, the master maintains a list of all that information. So even if vCenter goes down, the master still knows what's out there. And it acts as the interface between vCenter and the rest of the hosts in the cluster. So in general, vCenter doesn't talk to each one of the cluster hosts. It talks to the master, and the master then goes and informs the slaves that they have an activity they need to perform or they need to provide information back to vCenter. Cool. And this is what clustering might look like, and you'll see this is actually a superset of the diagram I used earlier, where you have VMware infrastructure, or vCenter effectively is what this is on top, and it is used to manage your 3 hosts in this example. And so it keeps track of, so it records and then passes to the master the details of all the virtual machines and all the hosts that are involved in the cluster and the kind of configuration that's been done in terms of clustering and things like that. So HA clustering. So HA provides the ability to migrate VMs from one host to another in the case of a host failure. So if we go back to this picture, if host 1 falls over, the left-hand host, if it falls over, what HA does is it says, right, I'll take these virtual machines and I'll move their state across to these other 2 hosts and bring them back online. So the way this operates is that now this is crash recovery, and this is important when we talk later about fault tolerance, but effectively the effect of an HA event is as if the virtual machine crashed and booted again, like a cold reset. And as I mentioned here, if seamless failover is required where there is no crash of the virtual workload, you need to look at fault tolerance. It's one of the options that you can look at. So there are cluster heartbeats between the master and slave hosts every second. The cluster heartbeats are sent over the VM kernel ports, so your management ports. So again, if your network bandwidth is constrained, if you're using 1 gig ports instead of 10 gig ports, you're probably best to have separate VMK ports for this to your data or storage networks. You may have multiple VMK ports, then allocate that some of them are used for cluster operations, some of them are used for storage. There are 3 types of, just on the cluster heartbeats, data store heartbeating is used as a secondary failure detection mechanism. So if the master doesn't get a response back from one of the slaves, what it will do if you've configured data store heartbeating is it will go look at the data stores that are configured to see, is there a lock file owned by the slave that it's lost sight of on that data store still, that is active and held by that slave server. The reason it does that, there's 3 types of host failures, failure types that are monitored. So the host is offline. So the host has completely dropped its bundle. It's no longer online. It's not communicating on the network at all. So what would happen there is the heartbeat would fail, and also the data store heartbeat would be checked, and the master would detect that the slave no longer has the lock file open. So at that point, it would determine, right, that host, that slave host, has gone offline, and the virtual machines on that slave host need to be migrated somewhere else and started again. The second type of failure that can occur is network isolation, and this is where the host is powered on, but it's lost all its network connectivity. Effectively, as far as HA is concerned, it's the same as a host offline. If the data store heartbeating is not being held because the storage network has been lost and the cluster heartbeating is not being seen, then effectively the VMs are offline and they need to be brought up somewhere else. However, in this case, when the slave server detects that it has lost contact with the master, it will actually then, it can be configured with an activity should it shut its virtual machines down, because it may have virtual machines running on local storage. No, they wouldn't be local storage, but they may have access to virtual machines. on data stores that aren't being data store heartbeated. And so we can say, you know what, I've lost my network, I've been isolated on the network, I'll go shut my virtual machines down because I know the master is going to go inform another slave to pick the workloads up. There is also then an issue called network partitioning. So this is where the host is powered on and has network connectivity. It can see some hosts in the cluster, but not all of them. And this is a different issue where, in general, the master will not restart the virtual machines because the host that it has lost contact to still has those lock files in the data store heartbeat section, and therefore it knows, no, although I can't see it over the management network, I know it's still online, I know it's probably still executing virtual machine operations, and I'll probably leave the virtual machines alone. You can configure the behavior at that point, but that's the way it generally works. Now, another part of HA clustering is something called admission control. So let's say you had 4 virtual hosts in a cluster, and each one of those hosts, when the loads were balanced, was at approximately, let's say, 75% fully utilized. So of all the resources it could provide, 75% of those resources were either consumed or reserved on each host. So if one host failed, that 75% has to be spread across the remaining 3 hosts. 25% of the workload per host, or of the resources per host, just fits in, literally. You end up with 3 hosts operating at 100% capacity. However, if another host failed, what admission control would do is it would determine that, you know, I can't actually cope with that additional workload. The 2 remaining hosts can't cope with that workload. They're already 100% committed, therefore I won't start the virtual machines. And you can set priority in this, that certain VMs have priority, but basically what this does, it prevents a host from being overloaded with either existing workload or reservations. So again, if you have guaranteed reservations to virtual machines, and a reservation is a guarantee of resources that no matter what happens, a certain amount of CPU and RAM will be available to this virtual machine. If that reservation cannot be satisfied by booting additional virtual machines on the host, then the virtual machines will not be booted on that host. And the cluster will either look elsewhere to bring them up or won't bring them up at all. It can also work on a per host basis where you say, I've got a cluster of 4 virtual machines. This cluster can cope with 1 host failure. Any more than that, don't bring up the VMs again. So when that first host fails, the admission control says, yes, 1 of the 4 has failed. I can bring my virtual machines up. I've been told from my admission control configuration that I can do that. If a second host fails and the cluster has been configured for any single host failure, then the virtual machines from the second host that has failed will not be brought online. Now, vMotion, and the reason we get to vMotion is it is important for the second style of clustering. So now, I guess probably, are there any particular questions
sorry,
we
Robert,
should look at?
Yep. Yeah, sorry, Robert, just to interrupt, we've got a few questions in there. Can you see them at the top?
Let me see if I can arrange my flags. Yeah, have you flagged them red or orange for me?
No flags, just they should be right at the top above the green ones.
Okay. Let's just, yeah, I'll pause for questions in a second. Let me run through 16. So you might see my mouse moving around as I'm trying to get the questions. Okay. Do we have any idea what we can do to practice on workstation 12 for clustering? You could actually bring up a second ESXi host. We talk about that in the lab setup. And you can play with DRS and HA. It does require that you've got a fair amount of resource available. Yeah, it can be a bit tricky. In ESXi 6, does DRS still operate if Vim is stopped or offline? So you said Vim, the virtual infrastructure, so I assume, Jeff, that means the vCenter server. Some of those operations, yes, they do continue to execute because the cluster has been told in the event of a vCenter failure how it should continue to operate. So yeah, vCenter can be offline for a period of time and the cluster operations should still continue. DRS does require vCenter server, yes, and so does HA. You cannot do HA without vCenter. DRS, there's a limited amount of work that can be done by DRS with vCenter offline for a period of time. HA will generally, again, bring things up and last longer, but DRS, as I understand it, still does allow some level of operation while the vCenter server is offline. Yeah, certainly VMware have almost never said you should cluster your vCenter servers. You should have more than one. There's some options for that in 6.5, funnily enough, but they've never recommended that best practice was that you cluster your vCenter servers, because if one of them goes down, all your enhanced functionality will fail. They've actually built some resilience into it. Can you set rules for resource allocations or preferred failover hosts? Absolutely you can. I will get to that when we talk about DRS. If the vCenter machine is on the ESXi host, so what happens if the vCenter server is on the host that fails? Because there is that master-slave set of information, the master will bring the vCenter server back up on another host, as long as it's part of the protected workloads, which VMware used to recommend, and going back to 3.5, where ESX was still the hypervisor, that you actually ran, it may have been version 3, we're going back a while, that you actually ran vCenter on a separate physical server and it was not part of your VMware infrastructure cluster. That recommendation stopped being current around 3.5 or 4, I think. It's quite some time ago. So certainly best practice these days is that you virtualize your vCenter server and you put it in your cluster that vCenter controls. Anthony has asked, am I a fan of SRM? Yes, I am. There are other tools that do similar jobs. I think SRM is a very interesting tool. I've used it in anger. SRM, or Site Recovery Manager, for those who are not aware of what the acronym stands for, is a set of tools from VMware that allow you to replicate workloads between one cluster and another and bring them online in the event of a disaster. It also allows you to do sandbox testing of your disaster and scripting of it and failback, and there's some really interesting stuff it does. If you need to do DR from site to site and you have the capability, SRM is one of the tools you should look at, definitely. If a host recovers from a power failure, does it rebalance the load? It depends if DRS is on. We'll get to that in a moment. How is the cluster protected from split brain? David, can you, I assume what you mean there is that if the cluster, one of the hosts doesn't entirely go offline, but it loses network connectivity, that's where those 3 failure modes occur. And again, where you have that host isolation response. So one of the configuration items in your cluster is host isolation response. What should the cluster do, or what should be done with the workloads in certain circumstances where a host may not actually be entirely offline? And that's where I talked about, you may set your host isolation response that if the host believes it's lost connectivity to the rest of the network, so it can't see anything else at all, what it should do with its virtual workloads. Yes, Michael, you're right. As I said, 6.5 changed HA for vCenter itself. I wish I could have gotten to vForum. Unfortunately, I have other things going on. Just going through quickly, making sure I get the questions. Like to know if the cluster features, is it necessary to have physical hosts the same? We'll get to that later. The answer is it depends. You can do with different hardware, that is possible. Is the shutdown guest a comfortable shutdown? It can be. It can actually be. Sorry, I've just had a cramp in my leg. Guys, give me a second. Oh, this is a good one. I just need.
I will take over and say welcome to week 4, question time. We'll get back onto the lecture soon. While we're waiting, we've had a question from Nathaniel, SRM or Veeam. So I'd be interested in maybe getting some thoughts of the audience, see what they've been using. Yeah, I'd like to also welcome everyone for the first day of the Donald Trump President-elect. Is that a word? It is now. There will be a prize for the best Donald Trump joke. Keep it clean. I don't have a recording of the girl from Ipanema, so we can't have wait music.
Okay, I am back. Terribly sorry. Nasty.
We won't need to wait. Wonderful, wonderful.
Nasty leg cramp. I do apologise.
Welcome back.
Thank you. SRM or Veeam? It depends. SRM has some particular functionality. Veeam is an alternative. It really does depend which one suits your environment more. and your cost structures possibly, because I think Veeam might be cheaper in certain environments. What's the process when a master fails? There is an election. So once the slaves will recognize they can't see their master anymore, then they have an election. No HA leg. Yeah, no, I had a second leg. I was hopping on it. Going through this very quickly, checking questions.
I'll do some sorting. Let's get back on track, and I'll get some plans for you.
The one I was answering when my leg cramped up was, is the shutdown guest a comfortable shutdown? You have both options. You can power them down, which is a hard shutdown, or you can do a guest shutdown, which is when the VMware tools, and they are required for comfortable or nice VM shutdown, where the VMware tools actually goes and tells the operating system, please shut down gracefully. Drink more beer for the cramp. It's funny you say that. I gave up alcohol for the year, so I haven't had a drop of alcohol since January 1st.
Nice work.
Some would say that. Alex
goals,
Lance,
life goals.
Alex Lance, and I wonder if that's an Alex Lance I've known in a past life, has mentioned Zerto is better than Veeam is better than SRM. I'll take your word on that, Alex, because I haven't used Zerto. Orange is the new black, yes. Okay, we're getting into the Trumpisms. I'll eat more bananas, absolutely. Potassium is a great thing to prevent cramps. I think SRM is Site Recovery Manager. It is a way of replicating your workloads. It actually does rely on integration with the array, yes, although I believe there is also vSphere replication is now an option there as well, where instead of relying on the array to do the data replication, you can actually replicate the data on a per VM basis. Yes, we're talking about ESXi elections, and then we're talking about a Trump election. Very good. I think I'm done on questions that are actually relevant to the course, so I shall continue.
Yes, we're being flooded by a Trump joke, so please abstain. Thank you.
If only he would. Okay, vMotion. So vMotion is the feature that is used to migrate VMs from one host to another. The way it works is the memory footprint of a virtual machine is copied from the source host to the destination host. Effectively, a snapshot of the memory footprint is taken, and that snapshot is transferred. Then a second snapshot is taken, which is the delta, the difference between when the first snapshot was taken and the second, and that's transferred, and that's smaller, because you would hope. And then a third one might be taken, and a fourth, and eventually it gets to a point where vCenter and the virtual, your ESXi hosts make a decision that I can pretty much take a snapshot, copy across, and transfer ownership of the VM without the user noticing. And that is the final cutover. At that point, the VM is unregistered from the source. It is then registered on the destination, and the virtual machine memory footprint is effectively live on the destination host. VMware, and again, I think you're going back to, it may have even been ESX or ESX3. They demoed this at VMworld in Dublin, where they were actually streaming video off a virtual machine, and and I think it was even the keynote, and they actually then showed on in a picture-in-picture window that they were vMotioning the virtual machine that was streaming the video from one host to another, and the video largely didn't flutter. So that's how good they got at it back then, and it's only improved since then. There are some workloads that don't like it. There are some particular workloads I've run into in various industries that are actually so sensitive to networking and memory footprint that they do notice a vMotion event. Funnily enough, actually, Skype for Business Server 2015, I've noticed, is not the happiest thing when a vMotion event occurs. It does require vCenter because vCenter is used to facilitate the move. And it's a function that is available only through VMware. So DRS clusters rely on vMotion. This is why I get to vMotion, because we'll talk about DRS in a moment. But they rely on vMotion to migrate the workloads between the active ESXi hosts within the cluster. So vMotion is the tool that is used to achieve a lot of the results that the DRS provides. So it requires the hosts have compatible hardware, and there was a question about this before. So, so basically, the destination host must be of the same architecture as the source, and at least the same generation. So without EVC, which I'll go into in a moment, you must be moving from Intel to Intel or AMD to AMD. You can't cross between Intel and AMD. And the destination, the generation of the architecture, so it might be a generation 4 Xeon CPU, has to be at least the same generation as the source. It cannot be older. The reason for that is that the virtual machine that is running on the source may be relying on some of the functionality that is provided by the CPU, and that's the physical CPU in the host. And so if there is a chance that that functionality is not available on the destination host, then the vMotion will not be allowed. The way you can get around that is through something called Enhanced vMotion Compatibility, or EVC. And this allows a cluster to be built with multiple architectures and or generations of hardware within that cluster. The way it effectively works is it looks for the lowest common denominator feature set for the cluster. So if you've got a generation 3 and 2 generation 4 Intel Xeon CPUs, it'll say, right, generation 3 is the oldest one I've got. All of the hosts in here can at least match the feature set of generation 3 Xeons. That's the EVC mode we're going to run in. And so effectively what it does, and one of the reasons it may not be the best thing for you, is it can strip away some of the functionalities that are offered by the later generation CPUs. So Gen 8 to Gen 9 or Gen 10 to Gen 9, if you're talking about the, let's say an HP ProLiant Gen 8 to Gen 9 or Gen 10 to Gen 9 in terms of ProLiant hardware, Jerry, then as long as the CPUs are the same, so to be a E5 something, Xeon E5 something or a Xeon E3 something internally, as long as that's the same, then yes, it's the CPU architecture that matters. I believe vMotion is supported with RDMs, yes, is another question, because in the past you weren't allowed to do it. It must be Intel to Intel or AMD to AMD. Yeah, I'm not sure. I thought EVC allowed cross, but you might be right, it may not. I'll confirm that one. I've never been in an environment where that was considered. I've worked in pure AMD environments where there's multiple generations of AMD CPUs. I've worked in pure Intel environments where there's multiple generations of Intel CPUs. I've never actually worked where both have been available. It tends to be topical, a Republican versus Democratic or Democrats thing. Some people like AMD, some people like Intel. It's quite rare to find people who have to use both. Does EVC auto select an ESXi6? No, it does not. You must turn it on. Is a cluster functionality that you would turn on. Is there a difference between vMotion during unplanned downtime and no? So effectively, and hand in the air, I've done it. I have vMotioned workloads during production hours without the users noticing. We have used the functionality to take hosts down for patching without the users knowing about it, because we run change control in IT, and our change control says the risk of the users noticing the workloads being moved around is low enough that we're happy to do that during production time. So one of the benefits you get out of clustering, and I didn't really touch on it as clearly before as I might have, is that vMotion and DRS and things like that, is that it allows you to actually, as long as you've got the capacity to do so, to take all the VMs from one host, vacate them, you put the host into maintenance mode, and it will do it, or largely do it automatically for you, go and do things on that host, and then when you bring that host back online, so you might patch it, reboot it, when you take it back out of maintenance mode, if DRS is turned on, then it will actually go and rebalance the workloads back to that host for you. Even if you don't have DRS, you do have an HA cluster, you still have vMotion in general, and you can manually manage that process. So manually go and move your VMs off the host you want to perform some operations on, then execute your operations, and once you've finished, then make sure the host is fully back online, and then manually move your host back. So the question before regarding the split blame, split brain is if the management network is split and the hosts end up in a state where there are two masters exist within each half, then there would be an election again. If you remove the okay, so there's a question then if you, so say you had a generation 3, a generation 4 and a generation 5 host in a cluster of 3, and you added another generation 5 server or server with generation 5 CPUs in it and removed the generation 3, would the EVC cluster automatically upgrade to version 4? No, it won't. So what you'd actually have to do is break down the cluster and then re-establish the cluster in EVC mode using generation 4 CPUs as the baseline. The question about does EVC allow vMotion between AMD and Intel hosts, I will have to clarify that. DRS, is it centered around CPU usage or memory usage? Both. We'll keep going. There's some more questions. There's a mix we're still talking about Trump. So when we're talking about generations, I'm talking about the generation of CPU. Generally, Intel will label them E3s or E5 Xeons, or they're known by their code names. So I don't remember some of the CPU code names offhand, but yeah. So does vMotion rely on only memory? Look, vMotion on its own, so vMotion, there is also storage vMotion, which is a little bit different. Sandy Bridge is one of them, thank you, Craig. There's a few different generational names, they're code names for the generations of CPUs. So vMotion is all about moving the memory state of a virtual machine from one host to another. It relies on both hosts having access to the same base storage, so the VMDK files can be viewed by both hosts. Because obviously as the VM continues to operate, then the virtual machine needs access to the underlying storage. Explain the process of breaking and rebuilding a cluster. You would literally, so when you create a cluster in vCenter, it creates a hierarchy which has a cluster and the hosts that are added under that cluster. So you can actually go right-click and on the cluster and turn off clustering. And what effectively happens is all the virtual machines stay running where they are. So the virtual machines stay on the hosts they exist on. They don't get moved as part of breaking down a cluster. And then you can go create a new cluster and add the hosts back to it, and those hosts will be dragged back into that cluster and all the working virtual machines will then be part of that cluster. Some things you might lose if you do that. Now, if you were running a DRS cluster and you were using resource pools, which allows you to set prioritization if there's resource contention within the cluster, then you lose those resource pools when you shut down DRS as a cluster. But certainly the workloads do keep working, and as long as you're not looking at significant amounts of effort to rebuild your resource pools, and again, I've done this in the past where I've had 3 resource pools and have good documentation on where all my virtual machines exist in terms of that, then that can be done absolutely. Explain more on the zero downtime with vMotion. So literally, the memory footprint of a virtual machine is actually what is running in the virtual machine. So at any point of time in any computer, anything that is happening on that computer is contained within memory. So the RAM is used for that. The CPU may execute commands, but the CPU takes its instructions from data in memory. It is executed through software which is stored in, which is read from disk possibly to memory, executed and then written back to disk. So vMotion takes the memory footprint of the virtual machine. So if you've got a virtual machine with 4 gig of RAM, effectively that virtual machine has a 4 gig memory footprint, and that what happens is a snapshot of that memory footprint, so a copy of it at a point in time is taken and transferred to the destination host. Now, while that transfer is occurring, when that snapshot is taken, a delta copy, so any changes to the memory footprint on the source are tracked. And so once that first copy is done, those changes, there's another snapshot taken, and that set of changes is then copied from the source to the destination. And every time that occurs, in theory, that copy is smaller, so it takes less time. at some stage, VMware, the ESXi hosts and the vCenter between them, make a decision that I can actually take a copy, transfer this across in such a small amount of time that the user of the workload won't see it occur. And at that point, that's where the virtual machine is deregistered from the source. That final copy of that last little bit of memory change is moved across, and the virtual machine is re-registered on the destination host. I will put some information up in the forums about this. There's some really good information from VMware on how this works. vMotion, I'll go back to the slides because otherwise we're going to miss. I don't think I've got any more questions I haven't answered yet. We'll keep going. So, and this is this memory footprint that I mentioned effectively. So a snapshot is taken of this virtual machine memory footprint and it's transferred across here. In the meantime, this amount of change has occurred. So it's copied across. And the time that change is copied across, because it's smaller than the original memory footprint, a smaller amount of change has occurred. So it's copied across. And gradually it gets to a point where there's no requirement to continue snapshotting and copying, so it finally makes a copy across. A comment then, I thought the cluster's EVC mode could be reconfigured. My understanding is that it can't. Now the EVC mode set on the VMs, the VMs themselves don't track EVC mode as such, but the metadata file, the VMX file, does track effectively what virtual CPU functionality has access to. And that's one of the reasons why I don't believe you can simply reconfigure EVC mode. If I'm wrong, more than happy to admit it. Let me go and find out, but I didn't think that was the case. Would I recommend VM to host affinity rules? Sometimes is the answer there. So you get affinity, so an affinity and an anti-affinity rule. And I get to those in a moment, so I'll talk about them when I get there. But yes, that is a distinct possibility that you might want to use affinity rules.
For reference or for information, folks, I'll just start flagging questions for perhaps the end of the lecture, so we might not get many answers in the next sort of few minutes.
Yeah, we're almost at 9 o'clock. Okay, I think I've answered most of the ones here anyway. Okay, so, and storage vMotion is largely done the same way. I mentioned that before, where effectively a snapshot is taken of the VMDK file, is transferred to from one piece of shared storage to another level of shared storage. And then in the interim, if there's been any changes to the source VMDK, then a second snapshot is taken, the delta of what has changed since the first snapshot is taken is copied across, and the same process occurs within the VMDK files instead of within the virtual machine memory footprint. It's a very similar process. In a vMotion event, the source and destination are the memory capability of the hosts. In a storage vMotion event, the source and destinations are virtual machine disk files stored in either VMFS or NFS file stores. So DRS clustering. So we've talked about this a little bit already. So DRS clustering provides three key capabilities. Load balancing, and there were some questions about this before. So really it ensures that the virtual workloads are balanced across the cluster resources. So, and you can determine how aggressive it is in this. You can set whether you're happy to have virtual machine workloads flipping around left, right, and center as minor changes occur, or if the DRS algorithms are going to be a little bit more conservative. And again, we say that with Donald Trump just having been elected to President of the US. And the DRS events will only occur when there's significant unbalancing. So it also allows prioritization of workloads through granting access to shares of CPU and RAM resources. So effectively, you can prioritize your virtual machines, and the shares are only used if contention occurs. So this is one of the things that people think, oh, if I grant this virtual machine a higher set of shares or access, shares of access to the underlying resources, then it will always run faster. It will only run faster if there is actually not enough of the resource to go around, and the resource, or access to the resource, needs to be rationed. So that if you've got 150 requests for 100 items of resourcing, obviously you can't service them all at once, and prioritization starts to take effect. And the way it works is that your shares are basically, look, if I'm breaking it down into 100, what percentage of that resource I get access to. And this can be done on a, and I mentioned this before, a resource pool level. So you might determine that your critical servers have access to 50% of the resource in the event of a contention event occurring, so that they are always guaranteed that at least 50% of the resources will be available to them. And you might have your lower level virtual machine resource groups set to have lowering levels of resources. So what that means is if there's 3 requests for resources but only 2 resources available, it determines who gets them first and what percentage of them it gets at any one time. DRS also allows dynamic power management, or DPM, and I should have a capital M there for management. What this does is it uses your DRS capabilities in your vMotion to determine that if my virtual machine, overall virtual machine workload can fit onto a fewer number of cluster servers because it's quiet, then what it will do, it will vMotion those virtual machines across to free up entirely 1 or more hosts in your cluster and actually shut that cluster, that host down. So if you had 3 hosts in your cluster and you could actually run all of your workload quite happily on 2 hosts, it might actually shut, vMotion all the workloads off one of those 3 hosts, move them off and shut that host down. As the workloads then become increasingly busy, so if that was overnight and once 8 o'clock in the morning it starts getting busier, using a wake on LAN or magic packet, it can actually go and wake up that host that it shut down earlier, bring it back online and start transferring virtual machines to that host to ensure there are sufficient resources available. The other thing it can do is virtual machine placement, which, and we talked about affinity before, or there was a question about affinity before, which can determine that when a virtual machine is brought online, so when it's booted, on which host it will be powered on. And that can be based on load balancing. So if 2 of your hosts are fairly busy and the 3rd host in this 3-host cluster is not very busy, chances are that virtual machine will be brought online on the less busy host. However, if there's been an affinity rule that says this virtual machine that is about to boot should always be on the same host as another virtual machine, then it will be run up on that other virtual machine, and as a secondary option it might determine that, well, in order to balance my workloads I'll go move other virtual machines away. Or you may have an anti-affinity rule, and you might have that you have certain virtual machines that you never want on the same host because you don't want a single host failure to take them both offline. So this might be things where you're running Windows clustering inside the VMs, or other, you might have static workloads that are shared across behind a load balancer, and you may actually put a rule in place that says, I've got 3 hosts and 3 virtual machines. These 3 virtual machines should never, except in the event of a host failure, share a host. So they should always be split out. So that's where your affinity, affinity rules come in. It does require Enterprise or Enterprise Plus licensing. I say this, it used to be Enterprise, you can no longer buy Enterprise, you must buy Enterprise Plus now if you want DRS clustering. VMware made a decision, I don't necessarily agree with it, that nobody who wants just Enterprise for DRS clustering doesn't also want the full Enterprise Plus license set. I was a customer who was very happy with my enterprise licenses. I still do get to have them supported until 2020, but certainly maybe I was one of the edge cases. There's always that thing that everyone else is actually not like me. So you can do then HA and DRS clustering together in one cluster. So that combines the benefits of HA and DRS onto a single cluster, prioritizing and balancing your workloads across the hosts, and providing failover in the event of a hardware failure. So it can actually also provide faster reallocation of resources due to hardware failures or maintenance events. So it can actually, the algorithms that form part of DRS can be used to bring virtual machines up quicker than HA actually would on its own, because there are some calculations made that says, you know what, that host has failed, that's great, I need to HA those machines, those virtual machines across, and DRS says, well, looking at the workloads of those other 3 hosts, you should probably bring them all up here because that's the that's the host that actually has the most processing capability or memory allocation that can bring them up faster. HA otherwise is pretty much, it doesn't really think too hard about where it brings them up, except for your emission control rules. So it'll bring them up on the next available host effectively in the cluster. So it does introduce some complexities. So there are some of the rules that can be a bit funny, that if they operate together they can cause some odd behaviors. And as an example with that, if you've got HA disabled, then failover resource availability requirements or your emission control are not considered by DRS. So it doesn't care whether there's actually enough resource to satisfy the reservations of all the workloads. It will just bring them up anyway. And that could lead to performance problems if you've got workloads that you are specifically granted not only resource allocations but also reservations, and those reservations are not being met. If HA is disabled, then DRS doesn't care about them, about those requirements. I mentioned fault tolerance before. So an HA event is effectively the virtual machine crashes and is powered back online. Fault tolerance provides near seamless, and nothing is ever truly seamless, failover of a virtual machine workload in the event of a hardware failure, and is a failover where the virtual machine effectively does not crash. You enable this on a per VM basis within your cluster. So it creates a second virtual machine on a separate host in the cluster, which operates in lockstep mode with the primary virtual machine. Effectively what it does is any change to the memory footprint in the primary copy of the virtual machine is also made in the second virtual machine as instantaneously as possible. So the lockstep copy contains an identical memory footprint, and it uses the same underlying VMDK file these days, or you can use the secondary copy, but that was one of the advances that vSphere 6 brought over 5.5, is you can actually use the same underlying VMDK files within shared storage. Under 5.5, you actually had a separate copy of the disk files as well. So when a failure is detected of the host where the primary copy is detected, the secondary VM is activated immediately. It is literally, oh, that one's gone, this one's up. It's that instantaneous. I say that as a person, think of a computer processing the difference. So it's a lot faster. There are some limitations on virtual hardware. So you can only have 2 virtual CPUs in standard or enterprise licenses of vSphere, 4 virtual CPUs in Enterprise Plus. You require, as an absolute minimum, 1 gigabit per second interconnectivity between the hosts. They do recommend 10. There is also, so the other thing that happens as well is if you've got more than 2 hosts in your cluster, if your first host fails, and that was where the primary copy of the VM was sitting, the secondary is activated, and then that effectively becomes the primary, and another secondary is created on another host in the cluster. So it immediately goes and re-establishes fault tolerance capability for you, as long as there are other resources within the cluster to cope with that. The vMotion EVC compatibility requirements apply as per DRS clustering. So you need to have those requirements met for fault tolerance. And this is what it really looks like. So there's no reboot. With an HA event, if the host in an HA event, if the host in the middle failed, these VMs would go offline and be brought back online on these other hosts, and there's a delay while that occurs. The virtual machine literally has to boot. Post is quick in the virtual machine, but it does take time. In a fault tolerance, there is a copy always kept on a second host, and you'll notice here that it will try to balance where the secondary copies are kept within the cluster, so that you don't have all your secondary copies on one secondary host effectively. And if this middle server fails, then the fault-tolerant copies of these virtual machines are immediately brought online. And once they're online and fully operating, what will actually happen then is that fault tolerance will take this copy, which is now a primary copy, and go create a secondary copy over here, and vice versa, in order to maintain the fault tolerance requirement. Very quickly, vCenter security, we're almost at the end. I know we're running over time again, although not by as much as we have in the past. So vCenter security is really managed as follows. So you have 3 aspects that are used to manage security on all your items within vCenter. So privileges, which are fine-grained access control. You then group those privileges into roles, which we'll talk about a little bit later, that you can map to user groups, to users or groups. So a privilege might be that a particular operation, so the ability to manipulate virtual networks, so to create a virtual machine port group as an example, is a privilege. Each object in vCenter has associated permissions. So the permissions are then, a particular user has a permission to work on a particular object and to carry out certain privileges. And the roles are effectively groupings of privileges. So you might have a role which is a storage administrator, and that storage administrator role will contain a number of privileges that focus around manipulating storage. And what you would then do is you would then grant a user or a group that role, and you would apply that role to resources within vCenter. And because diagrams are nicer, so you have a set of privileges, and there can be one or more, that are built into a role. So a role is effectively a group of privileges. That role is then attached to an object in vCenter, and basically an object in vCenter is any item that you can see in the hierarchy, and then users or groups are then granted that role on that object. That's the way the security is applied in vCenter. We'll just go through questions quickly. Very good comment there. Affinity rules can be used for licensing purposes. So if you are licensed for a certain number of CPUs or hosts for SQL or Oracle or something like that, then that is the way that, that's one of the ways you can ensure that you are maintaining compliance with your licensing. How does fault tolerance work with VMware licensing? VMware themselves don't bill for CPU cycles. So you may find that you've got a provider who use VMware as their underlying technology, a cloud services provider as an example. You would have to check with them how they do that. Generally, it's a memory footprint, so they might charge for the memory. The CPU shouldn't be too much. DRS and HA in a cluster, yes, absolutely. I've mentioned that already. SSL certificates for the vCenter appliance, I can very briefly touch on that. You can either use self-published SSL certificates, so when you install vCenter, it provides some certificates automatically. Otherwise, there is a role. It is generally run as part of the Platform Services Controller, which is a VMware certificate authority, and you can actually grant that certificate authority the ability to issue certificates as a sub-authority to your enterprise PKI environment, so that it will then issue certificates to all of the virtual hosts, your ESXi hosts, and any of the other functionalities within vCenter, so that you're using properly signed certificates. But otherwise, the Platform Services Controller will issue self-signed certificates, which means you might get that pop-up, are you sure you wish to trust this host? And then click yes, always trust it, and run. It depends what your policies are around your SSL certificates. Can HA and DRS work with vSAN? Yes, they can. Absolutely. vSAN is shared storage, which then means the virtual machines on multiple hosts can see it and they can use it. Is there a bug in vSphere 6 web client? There's a lot. There are several bugs in the vSphere 6 web client, I have to say, where the permissions don't work with nested security groups, but works with the thick client. I haven't seen that particular bug. I have seen other permission-based bugs in the vSphere 6 web client. Apparently, it's all fixed, or meant to be all fixed, in the HTML5 web client on vSphere 6.5. Does fault tolerance require CPU resources? They need to be available so that if the virtual machine is brought up, then they have to occur. The virtual machine, your secondary copy of your virtual machine doesn't consume CPU resources per se, because the memory footprint is being provided by the hypervisor. So it's not like it's running independently and copying the commands. What's happening is the memory is kept in lockstep. Yeah, there are definitely the flings, which are VMware's open beta program for development, will resolve some of the bugs in the web UI. Absolutely. Thank you, Brendan, for noting that. Some people do have an aversion to relying on unsupported flings, but yeah, it is possible. Absolutely. Do we have any questions I've missed? I don't think we do. Good. I'll keep going.
The rest are played for the end.
Cool. So
and just to let you know, Alex Lance was that friend from the past. Hey,
Alex. Ping me on the forums. Yeah, actually, you should have my email address actually as well. So yeah, Flick me an email. Okay, so vCenter single sign-on, and this is again associated with the security aspects. So SSO, which again is a functionality of the platform services controller, provides federation or the ability to interact effectively, to talk to each other and share information between your existing directory services, such as Active Directory and vCenter. So removing the requirement for separate logon credentials to be maintained for vCenter. So what you effectively do is you create federation between Active Directory and your vCenter, and you add Active Directory users or groups into the groups in vCenter. It also means you can do the integrated logon with the vCenter clients. You can do that with the web client or the FAT client. So as I mentioned before, the SSO services are provided by the platform services controller. Groups from the external Active Directory, from the external directory server such as AD, can be added to groups within vCenter, which is then assigned to roles and permissions, as I mentioned before. So I say here groups, you can use individual users. Best practice is to use groups where you can, because that way you manipulate the membership of the group rather than adding and removing individual users regularly. And the same goes for when you're applying security permissions in NTFS or file shares. You're better to assign groups to those permissions and then assign users to those groups. It's a little bit more manageable. vShield, very quickly, and I say quickly, very quickly. So and this is one of those advanced features. It's been there for a while, but since 5.1 it started. So it's a suite of virtual appliances which provides security functionality, including antivirus, to vSphere environments. So you're talking about virtualized antivirus, virtualized firewalls, virtualized, I'll go through here, right? So vShield Manager is the overall management platform for vShield. You've got a vShield app. It's an application-aware firewall. It replaced vShield Zones, if you've ever dealt with vShield Zones. The vShield Edge, which is your perimeter security, so it's an edge device on the edge of a virtual network. You would generally implement this along with something like NSX. It provides some functionality to HTTP, NAT, load balancing, and VPN. So it allows you to provide security functionality as a virtual appliance within a virtual environment instead of using physical devices to do this, and also endpoint. Now, endpoint's probably one of the more interesting ones. Instead of running your antivirus application, so you might have a corporate Norton antivirus or Symantec antivirus as they call it now, or Trend, or any one of a number of different antivirus and anti-malware platforms, where traditionally you load an application into the guest or an agent into the guest, into your Windows or your Linux or whatever your virtual machine operating system is, and it sits within that virtual machine. It consumes CPU cycles within that virtual machine. It consumes disk I/O within that virtual machine. It consumes memory. And certainly, and one of the issues you get is that if you have a fairly typical corporate antivirus strategy that says once a week on a Tuesday at 3 p.m. I go scan my disks, then you can have a whole bunch of virtual machines all of a sudden send a whole bunch of I/O to your storage and slow down other processes. So what vShield Endpoint allows is that antivirus and anti-malware functionality done outside of the guest. So it's an out-of-guest solution. The way it works is you have a vShield Endpoint appliance that gains access through the vShield APIs or application programming interfaces to not directly to the memory within the VMs. There is a level of protection of that, but it gets to see what's going in and out of the memory footprint of the virtual machines, and that can be either what's being processed and created running within that virtual machine. So if there's a call to disk to load something to memory, that will be trapped by the vShield endpoint through the vShield APIs. It also can look at network traffic in and out of the virtual machines. And so rather than scanning within the guest, it's scanning from outside the guest. So instead of sitting within the guest and consuming CPU and RAM and disk I/O within your guest and possibly slowing down the workload that you're trying to provide to your users, it sits outside of it and watches the way that virtual machine interacts with the rest of the environment and may pick up and should pick up. It's actually pretty good technology that if there's activity going on in those environments that you want to know a lot more about or want to prevent. Like any AV or anti-malware, you can get false positives, you can miss things, these things happen, but it's a way of offloading the workload from each one of your offloading the resource requirements from each one of your workloads, your virtual machines, into a dedicated virtual machine that you can resource constrain or guarantee resources. And we're at lab setup. Any more questions before we keep going? Just quickly, I know we're running pretty much as past time as I normally run now, so it's good to know I'm consistent at least. Which version of licensing grants vShield? I believe it's Enterprise. So vShield, so the way vShield Enterprise works, vShield Endpoint works, is that the APIs are available through vShield, and then you go and acquire a virtual appliance, a vShield Endpoint virtual appliance from one of the major antivirus / anti-malware providers. Would I recommend it? Again, it depends. So if you're running virtual desktop infrastructure, so VDI, VMware View, and you've got a massive number of virtual machines with the antivirus workload would be fairly significant if you had to replicate it through each virtual machine. So in some environments, it absolutely works better. It can also be used if you've got a corporate standard of one particular antivirus product that you put across all your desktop fleet, that you can actually go use a different vendor in your virtual host environment, in your virtualized environment, to give you what security in depth, where you're actually using different scanning engines, different definition files, different ways of tracking, unwanted activity at different levels in your environment. Can it be configured with custom rules? It depends on, you can certainly, there's a lot of customization possible within vShield. vShield is this suite of security options that VMware provided. The vShield APIs are the ways that your products that fit into the vShield framework then interoperate with your environment. It's a framework that is made available, again, so you gain access to the APIs. It's done through the hosts, but it's a functionality that is only available if you're actually paying for vCenter, and I think it's Enterprise Plus. I think it covers on Enterprise. You can't buy Enterprise anymore. So yeah, that's a very good point Jason has made there, is that they're using it where he sits in their VDI environment, because you can actually monitor processes rather than files effectively. So instead of worrying about scanning all the files, what you're saying is, look, I'm going to scan any process that runs, and I'll do it in such a way that it's not intrusive on the workload, but it means that I'm not going to go create these IO storms when I decide once a week to go and scan everything for malware at rest on my storage. So yeah, it's definitely an option to look at if you're in an environment where offloading that workload from the virtual machines themselves to an external thing, being a virtual appliance, would be worthwhile for you to work. Can you enable it on a per VM basis? I believe you actually have to determine which VMs are covered by it. Yes. Now, getting back to the slides, because we're at the second or third last slide. I think the last one says thank you, and the last one says questions, and we've done plenty of those, but happy to do more. So for your lab, so if you have the resources available to you, and it's a little bit harder, this one, I do acknowledge that if you're running on a laptop with 8 gig of RAM and you've got VMware Workstation running, that you're going to be fairly resource constrained. But if you can, create a second ESXi host and connect it to vCenter. So you've already got one, in theory, one ESXi host with vCenter running, so try to create a second ESXi host and add that to vCenter as well. Then go enable HA and DRS clustering and look at the configuration options. I'm happy to discuss them, and we've talked about them in here for a while so far, but happy to go through them in more depth. Look at them, have a play with them, see what impact they have and what they tell you. So vMotion a VM from one host to another. So in general, you'll have a vCenter, which might be your VCSA, running on your first ESXi host. So vMotion it to the other host, see how it behaves. Given that you'll be doing it connected to vCenter by either the THIC or the web client, you should effectively see that there's no downtime as you do that. So with DRS clustering enabled, put a host with a VM on it. So if you've vMotion to your second host, put it into maintenance mode. What happens? I did talk about what would happen during the presentation, but what should happen? Actually see what it does, and then power off an ESXi host with a VM on it. So shut down that host that is running your vCenter server and see what happens. What should happen is what we went through is that the master server should identify, or whichever, the master, if the slave goes down, will identify the slave has gone down and will bring up the VMs. If the master goes down, the slave will identify, I don't have a master anymore, let's run an election, oh, it's just me, I guess I'm the master. It will elect itself the master and will take over the workloads. That's the way it works. Is there a way of protecting the host ESXi kernel against attacks that may target the VMware environments? That's a really good question, Brendan. One of the things that was done in the move from ESX to ESXi is that the size of the hypervisor was shrunk significantly. It was a multi-gig thing in the past with multiple interfaces, and there were a lot more attack vectors against it. And one of the things that was done in trying to minimize the size of the hypervisor was A, to make it more efficient, but B, also to reduce the exposed surface of the hypervisor. It's a lot more efficient. It used to be effectively you had something called the service console, which was effectively a hidden VM that ran Linux that gave you your management interfaces. What that meant was the hypervisor itself had its own potential attack points, and so did the service console. So they've removed the service console entirely these days. There is a CLI interface, but it is built, it's a native part of the hypervisor. It's a lot smaller, it's a lot tighter. The firewalling is more efficient. You can go and turn on and off various services, and you can turn on and off firewall against some of those services on your hosts. Of course, Ross, that's a very good point. Ross has made the point, it still has weaknesses, we just have to find them. The only secure computer is the one that you've turned off and unplugged from the wall. It has no power and no connectivity. How will the slave identify the tasks that run the master? The master maintains a list. It's actually written into the root of each of the nominated data stores, or all the hosts have access to. There's a list of data kept there. So if a master goes down, the slaves will go have an election, and then whichever one becomes the master will go take ownership of that list. And there's a good comment there that I mentioned powered off and disconnected from the wall and put in a safe, and the key thrown away, and the safe buried in concrete, and then the concrete set on fire, and then Donald Trump pressing the button.
I thought I was meant to be the Luddite here.
Not at all. Look, any computer that has connectivity and that somebody has physical access to is vulnerable to compromise. The most important level of security you can provide in any environment is physical, because in the end, if somebody can actually touch the thing, they'll probably compromise it in the end. Yes, both your ESXi hosts will need to connect to shared storage. For the lab, that is a good comment. You should be able to do that by provisioning storage out of your workstation, your VMware workstation environment. If that is not the case, I apologize. I'll see if I can find a way you can do it. There are things you could do. You can go in Windows, turn on the iSCSI subsystems and provision iSCSI storage back to your virtual environment. That's getting very obtuse and painful. I'll see if I can find an easier way to do it. Shared nothing vMotion. Kieran, I assume you're asking is it possible to do vMotion when nothing is shared? No. vMotion requires that at least the storage is shared and there's a common network between the hosts. Is there a way to protect the ESXi host from a purple screen of death caused by a guest VM? In general, a guest VM should not cause a purple screen of death. And those who are familiar with Windows will know there was a blue screen of death. VMware provides a lovely pink/purple. Chartreuse, there's a few names for the color. It's not, there's no official term for the color, I think. Magenta is another name. Yeah, it's a purple screen of death or pink screen of death. Also depends on what angle you're viewing your LCD monitor, what your color reproduction is like, things like that. Red Hat is a red screen of death, so does an Xbox. Oh, it's a red circle of death, I guess, or red ring of death. Really, a VM, or a workload inside of a VM should not be able to do that. There is meant to be and there is a definite level of abstraction between what's running within the VM and what's running on the hypervisor. Again, as was mentioned earlier, that by Ross, that there are weaknesses that we just have to find them. So there probably is a way eventually to do it. Whether the effort in finding it is worth the outcome. You can crash on bad RAM. The crash on bad RAM, the RAM contents for the virtual machine should be heavily and are heavily compartmentalized. So the hypervisor should not be relying on any memory that is also shared by a virtual machine. There are protections against that. There are also protections against the virtual machines causing each other to crash, even though the memory over subscription, the way that's done is basically through shared pages of RAM. So if you bring up 20 virtual machines all running Windows Server 2008 R2, there's a common set of memory that each one of those boxes will try to bring up. And one of the ways VMware provides memory over subscription is to effectively keep one copy and point them all at that copy until one of them tries to make a change to it, in which case another copy is spawned. It should be very hard for a vulnerability or an activity within a virtual machine to crash the hypervisor. I said hard, not impossible.
We've run about half an hour over time.
As I said,
again, Robert.
About normal. Yeah, again, that's correct.
Yeah, I think we're going about right.
And I'm happy that the reason we're doing that is because there's lots of good questions being asked. I'm really happy with that.
You guys have sent in all sorts of questions that have been fun to manage and really interesting. And I'd just like to thank Robert as well for sort of spending the extra time to answer. It's been really great. You guys have really been great this course. I like the Masterclass. It's quite good. We've got a few questions down the bottom, Robert, that have been yellow flagged. These are throughout the lecture that I thought might be good to discuss at the end, and then maybe we'll have a final word on the exam.
Cool. All right. So Alex said we'll do. Rob, cheers. Cool. Okay. So when the host in the cluster goes down, the VMs are migrated to the other host through. No, it's not through vMotion. So vMotion is only used when both hosts are up. So that's a DRS functionality in a cluster. So when it's HA, effectively what happens is the memory footprint of the virtual machine disappears. It's gone, right? So whatever was in memory on the virtual machine is gone. So if it was halfway through a process, you've lost that process. If it hasn't written results from that process to disk. So what happens is the vCenter and the host, the master host in the cluster, recognize that a slave has gone down, knows which VMs are on that host, and what it does is it goes attaches those VMs or allocates those VMs to other hosts in the cluster and tells those hosts go grab the disk and boot the virtual machine. Now the same as when a physical host boots, if it's powered off, there's nothing in memory. So as it boots, there's a process that copies the bootstrap from the disk and the master boot record into memory to boot the operating system, and then the operating system in the virtual machine boots, and then it loads its applications on top. So it's literally like you took your desktop machine, your desktop or your laptop, and if it's a laptop, you pull the power cable and the battery, bang, it goes down, dead, right? No activity, flatlined. And then you plug back in and you hit the power button again and it boots back up. So any work that you hadn't saved is gone. You've lost it. But in general, unless you've had a really terrible event, and it doesn't happen very often these days, and it happens even less with SSD drives, unless you've actually gone and damaged some of the data on the disk as part of that power down, your laptop or your desktop should boot back up, and so does a virtual machine in an HA event.
We've got a few comments from Jason, which I thought I might get a comment.
Yeah, so Jason mentioned that he believes that EVC mode can be promoted to a higher level, but the VMs need to be powered off and back on. Yet when they're powered back on, the VMX file would be modified to do that. I didn't think you could do that with the cluster in place. I will go and check. And certainly you're absolutely right there, Jason, is that to promote the EVC levels, so to increase the EVC level of a cluster, all the remaining hosts in that cluster must be able to meet that new higher level. So again, if you'd removed your lowest level machine, assuming Jason's correct, and he's now causing me to doubt myself, it is potentially possible that, yes, you could raise the EVC compatibility level of the cluster, but as you mentioned, and it might be, and that might be where I'm getting confused, is you can't do it with the virtual machines running on the cluster. So that could actually be correct. Whereas you can destroy the cluster and bring the cluster back online at a new level of VVC without shutting the virtual machines down. So that might be where I'm getting myself confused. I will go confirm that. Thank you, Jason. Again, it's
David's also
good feedback and questions.
Yeah, and on that note, David's put on top of that, only need to remove the limiting host, don't need to remake the cluster.
Okay. Cool. All right. I think that's it. I don't think there's any anything else that I've missed. Look, thank you everybody for your time. Now we'll go to questions, and we've done some questions, so we'll talk about the exam. Now, as Guy mentioned before, so the exam will open next Wednesday. Does it open at 8 p.m, Guy?
I think 8, yes.
Okay, so it'll open at the normal lecture time, and it is available for a week, and it closes at midnight, so you actually get a week and 4 hours.
Lucky buggers.
40 questions, an hour to do them. The questions will be taken from the slides and the comments that we've had. So generally the slides, I won't, I would advise, and as Guy recommended, don't cram, don't sit there next Wednesday or the Wednesday following thinking, oh gee, I've got 4 hours, because you won't even get through my presentations in 4 hours. So give yourself time, ask questions. I'm happy to answer them. I have been a little bit quieter on the forums this last week than I would normally be. I do apologise for that. I will try to be more active this week, knowing that we're working up to exams or exam time, as 40 questions are generally multiple choice. If you've followed the presentations, if you've gone through the slide decks, you should not have any problems. I don't aim to fail people, but what I aim to do is to bring people up to a level where they can pass the exam. That's my job. My job is to educate you to a point where you can actually go past the assessment task. So there was a question earlier, will you get a certificate when you pass the exam? Assuming you've met all the requirements and you pass the exam, then yes, there is a certificate at the end. It's a pretty piece of virtual paper. I think that's... Anything else I should mention about the exam, Guy?
No, I don't think so. Yeah, just if you do have any problems, any technical problems, make sure you email us at shortcourses@itmasters.edu.au. Other than that, yeah, just good luck, have fun.
Cool, and I guess to go back to the little ITPA presentation I gave at the start, I can be emailed at president@itpa.org.au. We will, as ever, be hosting the recording of this webinar on the our YouTube channel, and also it will be hosted on the learn.itmasters.edu.au site for the subject. So thank you all for attending. Please do ask questions, comment. Please do fill out the survey on the quality of the course. If you think I was great, say so. If you think I was rubbish, say so. If you think there's anything I can improve, say so. I'm not scared.
No, you're the better president. You're the better president.
Thanks so much for your... I was a US citizen.
Thanks so much for your insights and your expertise and your time in these lectures, Robert. It's been really good, and thanks so much to everyone for their input. It's been really rewarding. Great collaborative learning, which is what.
Thank you for attending, absolutely, and for collaborating. I could sit here and give a lecture in an hour with no feedback, and I wouldn't know if you guys were enjoying it or liking it or disliking it or learning anything from it. I have a feeling that people have gained something out of this over the last 4 weeks, and that makes me feel good. And that's, again, one of the reasons why we moved from Sage AU to ITPA. It's one of the reasons I continue to run the organisation. So thank you. All right, on that note, Guy, shall we draw it to a close?
Yes, let's call drinks.
I wish.
Thanks,
okay,
folks.
Thanks, everybody.
Oh, yeah, sorry. Yeah, well done on your year.
Almost. A month and a half and I'll be done. Actually, no, less than that. Cool. All right. Thank you, everybody. And I will catch you on the forums. Good evening or whatever it happens to be where you are.